Hey, everybody, and welcome to another episode of React Native Radio. This week on our panel, we have Tim Jung.
Hi, everyone.
I'm Charles Max Wood from Devchat.tv. Tim, I think we had you on, a week or two ago? Do you want to just remind people who you are, and then they'll get used to hearing you, and then we'll introduce our guest?
Of course. Yeah, my name's Tim Jung. I'm a developer on the mobile engineering team for the Call of Duty companion app over at Activision Blizzard.
Nice. Infinite Red has been designing and shipping and building web and mobile applications for 10 years. They're experts in React Native and passionate advocates for remote work. They also host North America's only React Native conference, Chain React, attended by hundreds of developers all over the world. I actually went this last year. It was a ton of fun. If you start a project after hearing about them on this podcast, they'll give you 2 free tickets. You can learn more at radio.infinite.red. And our special guest this week is Hugh. Hugh, do you want to introduce yourself?
Yeah, sure. My name's Hugh. I'm the founder and studio lead at a product shop in Manhattan's Chinatown. And, we do everything from design, development, user experience, and build things from, experiential marketing sites all the way through to native apps, websites, and most recently a mobile telephone, which I think we're going to talk about today.
Nice. Yeah. The mobile telephone thing is just fascinating. In fact, do you want to just kind of give us the 10,000 foot view on what it is and what it has to do with React Native?
Yeah, definitely. So we were approached a couple of years ago about building the software stack for this minimalist telephone. So it's a cell phone that's about the size of your credit card, a little thicker. And the core kind of concept of it is that it's minimalist. It has only the things that you need and none of the things that kind of like distract you and take your attention away. So it doesn't have any traditional apps. It doesn't have Instagram, Twitter, Facebook. It doesn't have a web browser. It doesn't have an email client or anything like that. It's designed to kind of be like a Swiss Army knife type of telephone. It's kind of capitalizing or going with the trends of today's kind of getting away from the distractions of the internet and giving you a piece of hardware that kind of like forces you to disconnect. And the way that it kind of interacts with React Native is that, we chose React Native to kind of build the view layer for the operating system's kind of hardware, software, firmware stack, which is kind of like a strange choice. And, I'm sure we'll talk about, some of those reasons why we chose that today. But high level, the entire view layer for this operating system is built with React Native and is kind of running as a embedded platform app in a fork of Android, and handling all the rendering that way. So, yeah.
That's awesome. It's really interesting just to look at this and go, wow, it reminds me a little bit of a Palm Pilot. I hope that doesn't hurt your feelings.
No, I mean, a lot of the inspiration that we had were from, the awesome Nokia phones like the 3310 and 3315. I remember I had one of those phones and you went in 2006 or something, and you could take it and you could just skim it down the street and then go and pick it up at the other end and it would still be working. And, that's kind of like the breed of cell phone that we were inspired by. We wanted something that, you could just have on you at all times, and do just the things you needed. So yeah, I mean, I use it a lot. I go light very often, and it's this amazing thing to do if you want to go camping or fishing on the weekend, and you just really want to kind of disconnect and get away from all of the distraction and loudness and noise of the internet. So yeah.
Yeah, I totally get the need or the market this is filling. A lot of the times today, smartphones, especially us as app developers, we're just constantly so distracted by our phones. It's kind of refreshing to see something that focuses on the minimalism.
Yeah, I mean, I don't know if anyone else does this, but I have recently started putting my telephone, like my iPhone, in the other room when I'm asleep, so I'll go and I'll plug it in my living room. And then I just have like an alarm clock in my bedroom. And just making this small change has like made my sleep so much better and so much more kind of predictable and reliable. And what really has kind of like blown my mind is just how much of a presence your own cell phone has on your kind of like mental state. You kind of always know where it is, and it's kind of like this portal into this incredibly fast and loud world that, you know, is happening on your phone. And when it's near you, your brain is kind of like weirdly connected to it and following it, even when you're not looking at the screen. So yeah, the whole philosophy behind this device is to give you a hardware way to kind of forcibly sever that connection. So yeah, it really works. You know, it's fantastic. So
yeah, it's super cool.
Yeah. One thing that I'm kind of curious about getting into the technology a little bit is, you know, it's kind of this minimalist phone that uses e-ink, which is what the Kindles use, not the old school Kindles and stuff like that. I think the current Kindles use it too, actually. So yeah. So how does that change the way that you use React Native? Because it seems like, you know, you still use kind of the component based, you know, approach to things and stuff like that. But your components, you're not going to have color. You're not going to have, it may not even get drawn the same way. So yeah.
It's a big reason why we ended up using React Native was because of this screen. So for anyone who doesn't know how e-ink actually works, it's really fascinating. It's a huge collection of physical kind of like bubbles. And in each one of these bubbles, there's all of these particles that are essentially like black and white. So if you just imagine kind of like a sphere with these particles floating in this liquid. And the e-ink screen has like a positive charge on the top and a negative charge on the bottom. And in order to change the color of the pixel, make it black or white or one of the 16 shades of gray, kind of like that it can handle, you apply a certain amount of charge to the top or the bottom and pull those caps, those little tiny particles down or up, you know, further away from the user or closer to the user to get that color. So it's deep down, it's like a very physical device, even though these particles are so tiny. So what it means is that there is a lot of kind of nuance to working with such like a finicky thing. Obviously, there's some great things about it. You know, you don't have the blue light shining in your face, and it doesn't keep you up at night. And you know, it's just like a lot better for eye strain and things like that. But because we are physically moving these like actual particles up and down, the refresh rate on the screen is quite poor, right? Like even in like the most kind of tuned versions and implementations of an e-ink screen, you can really only get 2 to 3 screen changes a second compared to, you know, an LCD screen, which can do like 60 or more. So what we needed was a way of kind of programming a modern reactive interface that could, on a lower level, essentially kind of batch and intelligently fold a lot of the updates that were happening in this like reactive interface and UI layer into single updates that were kind of like optimized and applied to the screen as soon as possible. So, you know, we looked at a lot of different ways of going about this, and there really weren't a lot of kind of like declarative composable UI frameworks for Java or Kotlin, which was surprising. I mean, there's a thing that's just come out called Jetpack Compose, but that wasn't out before we started work on the project. It was released after. And there's a thing called Litho, which probably would have worked for us. But you know, when we looked at all things considered, we just decided React Native was the way to go. And basically, kind of the way that it works, if I'm to give like a high level of how the React Native stack works with the actual updating of the screen, there's a few layers, right? So there is the React Native layer, and what it essentially does is whenever something changes about any component that is wrapped in this higher order component we have, it will decorate that component with kind of like this hidden field and give it all of the information it needs to pass through to Java and pass through, you know, to the Android compositor, what type of e-ink update should be associated with this change. So essentially, we call that an e-ink heuristic. And then when changes happen in the view tree, we have a view tree observer in Java, which essentially watches for all changes to that view tree, and then discovers these kind of these special tags that we're rendering into React Native. And it will kind of like analyze all of them, understand kind of like the screen area that has changed by measuring, that kind of that part of the view, and it will kind of like put that into a render queue, which we then kind of keep adding to over time. So there might be 10 or 15 renders that come through from React. And what we'll do is we'll essentially kind of batch all of those into a single change and apply that to the screen at one time. So essentially we're kind of like always observing what React is doing from the Java side, and using that as kind of like a control signal to then pass things down to the kernel driver, and apply those updates. So the programming model has been really fun. Essentially when we have a dynamic component, we just wrap it in this render prop style component, which will observe changes and pass them through to Java. So yeah, that's how it works, and it's been really successful. We've iterated on it 3 or 4 times, and now it is performing pretty well. So yeah, it's really nice.
So one thing that I think is really interesting about all of this is you're doing custom hardware, and you mentioned some things surrounding that you're communicating on an OS level. And really what I'm just curious about is you have this really great article on medium.com, which talks about, building LightOS with React Native. And you really get into the guts of working with the Linux kernel. Can you kind of talk a little bit about some of the challenges you faced having to work with such technical aspects of Android and custom hardware?
Yeah, definitely. I mean, some of the, and I want to be candid here and say that, we worked with an OEM or an original equipment manufacturer in Taiwan. And we worked pretty heavily with their engineering department to do some of this lower level work, because that's their bread and butter. They essentially, when they are rolling out these devices, they will often write, custom drivers to interface between peripherals and components. So in terms of working with those kind of like lower level pieces and building forks of Android that are, for very custom assemblies, the hardest thing, to be honest, is building Android, right? So if you're making changes and iterating and building like a driver for the kernel, you have to be building against the full Android code base. And there are techniques where you can make this a little bit easier and just build parts of the kernel and kind of replace that. But essentially what you're building is a flat image. And a flat image is boot loaded onto the device after every kind of like development cycle. So essentially you change some code and then you rebuild Android, which can take, if you're building the entire thing and you haven't got a particularly powerful machine, can take like an hour or more. And then you load that onto the device and you test your software changes and you hope they work. And obviously this is why we have type systems and all of this excellent tooling on that level, because there's just so much code that has to get built just so that you can kind of like test those changes, that the hardest thing about it is iterating and moving quickly. But as I said, there are things you can do where if you're focused on just one very specific part of like, let's say the Linux kernel, you can just build that in isolation and have like an image that you built earlier and just swap out, one of the binaries, and then kind of load that onto the device. So there's ways to speed up that development cycle, but it is, compared to web development or native app development, it is just like horribly slow. So yeah, that's probably one of the biggest challenges. Outside of that, it's just understanding things like, how to apply voltages to different pins on the device and kind of like conform to the spec of that hardware peripheral. I mean, E-Ink doesn't really give you an SDK at all. You kind of have to write these things, these custom drivers from scratch, and they give you a spec of how to kind of interface with it. But this spec is very much like, you have to apply this voltage on this pin at this time in the device boot up sequence in order for the device to be prepared to receive these other signals. So, it's really quite complicated. And yeah, to be fair, a lot of that work was done in Taiwan, and I oversaw a lot of the architecture, but I didn't write too much of that myself.
Oh, that's super fascinating.
Yeah, absolutely. One thing that I'm wondering is, let's say that I have an app that I've written for iPhone and Android in React Native. How much work is it going to be for me to port it to LightOS?
Well, so the unfortunate answer to that question is that it's not possible. Because the LightOS.
I mean, that's the one thing I like, right? Is that, well, besides JavaScript and, the component model and, all of the things that I like about React Native, one of the big deals is that I can deploy anywhere. So,
yeah. So let's talk about that for a second. So the Light phone, the team are very opinionated about what should and should not be on the phone, right? So the device itself is this philosophy that you should only be able to do this like subset of things that modern smartphones can do. So we have just rolled out what we're calling our tool store, and this is very new. And the only tool that you can install right now is a calculator. And the tool store is essentially a subset of these apps that run using JavaScript. So another reason why we chose React Native is because we wanted to create kind of like a developer environment and an SDK that could be open to all JavaScript and React developers. And the way that we are going about that is by kind of building this like runtime and environment inside of our LightOS React Native build. So the long story short is you cannot really build traditional React Native or just regular native apps for the LightOS, but we are rolling out an SDK. It's going to take some time, so don't hold your breath on this one. But essentially, all React Native and JavaScript developers will be able to build for the LightOS. And there will be kind of like a submission process where developers can submit their tool, and it will be kind of like decided on whether it's within the spirit of the Light phone or not, as to whether that will be accepted to our tool store. If it's not, it's always something that you yourself as a developer can kind of keep on your phone, but it won't necessarily be like available to the general public. So yeah, essentially an SDK written in JS that is going to allow you to write React Native, but within this kind of like sandbox that we're giving developers.
I actually find this super interesting. Charles raises a good point about React Native apps being usable anywhere, but I do at the same time think it's super cool that you're essentially building an environment where different developers could contribute what are essentially more simple apps. Today, you go into the App Store and apps are huge. They have a lot of ads. They're very complex. And this is kind of an opportunity to reimagine building a whole new wave of apps which focus on simplicity and just really going to your Swiss Army knife philosophy of just the focusing on providing the most important parts of an app's functionality to the user.
Yeah, and I mean, just also to speak to why we kind of like took this approach, like another reason. The e-ink screen itself is actually very difficult to work with as like a developer who's trying to make a reactive UI. And we've built like a lot of utility into kind of like our system that allows you to to have really fine-grained control over how certain components update and things like that, and how they affect the screen. So if you were building for the Light phone, regardless of kind of like how we allowed that to happen, you would still be needing to tap into kind of like these deeper SDKs and this like, you would essentially have to build for this device because the screen is so difficult to work with. You couldn't just ship an app that was designed for an LCD screen to this phone and have it work. And we tried, like some of our early R&D phases, we had like this different philosophy early on with how the screen would manage its updates. And essentially what we would do is we had this lower level observer that would watch the frame buffer in Linux, and it would kind of like diff two different frames, and it would kind of decide and try and understand what had changed on the screen and kind of just like do a natural update based on, this algorithm. But what we found is like after like months of iteration on that, we still weren't satisfied with the performance or the user experience of how the screen was updating. It still made mistakes. It still wasn't perfect. And eventually we realized we just need to be decorating things from the UI level and controlling it from that developer level, because doing it on this really low level and trying to have this algorithm that just manage the screen updates and allow the developer to do whatever they want just would never provide the best user experience. So long story short, you still kind of have to build for this device alone if you want to ship an app to it. So we decided to kind of like really own that ecosystem instead.
Yeah, I saw in this ecosystem too, you're providing things like you have an eink.js component. Can you talk about that a little bit too?
Yeah, so that component essentially just takes a render prop. And, the verdict's out on whether render props are, the best way to do these things. There's some reasons why we chose it over, higher order component. But essentially what it does is it takes this inner component, and as that component changes and as its prop boundary changes, it will do a new render, and it will take a few kind of high level props about the render itself. For example, what e-ink update mode to choose. There's 4 e-ink update modes. Some are full screen, some like flash the screen, and those flashes are necessary because often the particles in the e-ink screen will kind of drift and lose their exact position. And that kind of creates this ghosting effect where you can kind of see a little bit of the past screen on the new screen. So it's necessary over time to do certain flashes at certain life cycles of a component so that the screen can kind of like go back to a rich black rather than kind of like seeing this like little ghost of the screen that came before it. So choosing that update mode carefully for each component is very important. And being able to decide whether a component should trigger a screen update when the component mounts versus when it updates or when it's about to unmount is also another very important kind of like control level that you need when building components for this screen. So that e-ink component essentially allows you to declare all of those properties of the component underneath and manage how it changes the screen from a physical perspective.
Great.
Yeah. It's been through many rounds of iteration, but it works pretty well at this point.
When I'm building a new product, G2I is the company that I call to help me find a developer who can build it. G2I is a hiring platform run by engineers that matches you with React, React Native, GraphQL, and mobile developers that you can trust. Whether you are a new company building your first product or an established company that wants additional engineering help, G2I has the talent you need to accomplish your goals. Go to g2i.co to learn more about what G2I has to offer. In my experience, G2I has linked me up with experienced engineers that can fit my budget. And the G2I staff are friendly and easy to work with. They know how product development works and can help you find the perfect engineer for your stack. Go to g2i.co to learn more about G2I. Yeah, this is really, really interesting. So one thing that I've seen working on Android apps is that you have the Android, the management app, anyway, where you write Android apps and then you're able to test them out. And so you can actually see what it's going to look like on your screen. Does that workflow work with this particular device?
Are you talking about the Android emulator?
Yeah.
Yeah. So good question. Early days in the build, yes, we were using the Android emulator. But we got to a certain point where because we are building ultimately like a kind of a kiosk mode app that interfaces with the very deep parts of Android. I mean, this is a cell phone, so it has to access like the very deep telemetry pieces. It has to access things around doing updates over the air. It basically needs full platform permissions. In the same way that your settings app on your Android phone can basically touch every part of the phone. So in order to get those platform permissions, you need to be signing your own application with the same keys that the Android build itself uses as kind of like the highest level of permission keys. So what that means is when we build our React Native app that runs against the Light phone, before we ship it to the phone, even in development, right? Like even if we just like change one JavaScript file and hot reload it, we are code signing all of that code with the platform keys from the Android fork that we're using, those secret keys. They're highly sensitive, and we've gone to great lengths to make sure that they're, encrypted and hidden. We have like a lot of security protocol around these specific keys. And what that means is the app runs in this permission set that is much more permissive than a regular Android app. But unfortunately, you can't do that against it's very complicated to do that against the emulator. So at a certain point in our development process, we switched to building against the early development versions of the device. And the very first one that we have is actually this large piece of cardboard about the size of a textbook. And, it just has all the PCB and the e-ink screen and everything kind of splayed out with just like wires connecting all of the pieces. And, that's one of the very early development kits we were building against. But, soon we got cases, and soon we got things that looked like phones. And, we started developing against them, mostly so that we could have that higher permission set against the real firmware that we'd be shipping to end users. So that was really important to get right.
So one thing that you mentioned, is working with Android and focusing on that so much. But what I'm kind of curious about is how often do you actually end up having to write any Java or native code to get all this working versus like what percentage is actually just React Native?
Yeah, so I would say that probably 60% or more of the code that was written in this system is actually Java. We wrote a tremendous amount of Java. I haven't counted the lines of code, but it's in the many thousands. Somewhere probably between 5,000 and 15,000 lines of code. And a lot of that is interfacing into the platform APIs, right? So when calls come in, for example, we have all of these callbacks that are registered that fire things, in Java, which we then kind of like serialize into JavaScript objects and pass them back down to React Native. There's just a ton of that. For example, the main screen of the device, it's like the phone app or the phone tool. That phone tool, it has this like interesting. I mean, it's kind of modern and we're kind of used to this now, but it essentially kind of like batches your call logs, your MMS and SMS, and some other various things about a specific contact thread into like one long kind of activity stream. And when you go into the phone and you click into one of the numbers, it will show you all of these things. It's similar to how iPhones do things, but in Android, like in the stock builds of Android, you'll have a messages app, and then you'll have a phone app, and your call logs live in the phone app, and your messages live in the messages app. And we had to do like a tremendous amount of work actually to kind of like stitch all of this data together, because in Android, these are all SQLite tables, and they're kind of like separate, and they don't talk too well. And there's also tons of quirks around, if this is an international version of the same number that doesn't have the plus in, the +1 in front of it, there's like a tremendous amount of work you have to do to kind of like compare numbers and do this in a performant way so that you can deliver this data back down to React Native. So yeah, to answer your question, there's an enormous amount of Java and a little bit of Kotlin running on the phone. And that was, I would say the majority of the code we wrote.
Cool.
So what's coming next? What are you working on now, Hugh?
So coming next, at the moment, we are building a whole bunch of tools for the operating system. So we found that we have to be a little careful promising things because, a lot comes up and we often have to reprioritize things on the fly. But what I can say is that right now we are actively working on a podcast app, so we can listen to React Native radio on the Light phone. And following that, we'll be doing a music player and a few other utilities. that are kind of like necessary for modern smartphone users. There will be a maps component at some point where you'll be able to find directions from A to B in the most kind of simple way possible. We've tried some basic tests for actually drawing a map onto the screen, and it's really such a tiny screen with such a kind of like finicky refresh rate that actually drawing maps is probably not going to be tenable, but we'll be doing kind of like MapQuest style lists of directions. So right now we're really focused on just building out this like kind of core tool set. And then from there's a couple of things that we're some interesting things that we're doing in terms of kind of deeper telemetry pieces. For example, a lot of these light phone users, and if you're familiar with the very first light phone, the kind of philosophy there was that you could kind of use your light phone as kind of a mirror of your primary telephone. So if you got a call, both of your devices would ring, and you would pick up one of them, and then the call would stop ringing on the other. So we are looking into kind of like making those parts a lot more mature and bringing them to the light phone 2, so that, if you're someone who still needs your iPhone for work, but you want to go light at all other times, that's something that's very easy to do without having to kind of swap SIM cards and things like that. So yeah, I mean, something that we haven't really discussed on this call because it's not React Native specific is that our backend also can, provision SIM cards. So Lightphone actually is now offering its own telephone service. And you can request a Light SIM, you can plug it into your phone, and then you can go to our website and activate that SIM card and be running on the Lightphone network, basically. So we're kind of running this like mini telecom company around this telephone, and that gives us like the ability to kind of rethink how people want to interact with their SIM cards and their devices, and how people might want to kind of pair their devices and use them in different behavioral patterns. So those are the things that are coming next, and of course that SDK that I mentioned will come sometime this year as well. I hope.
Awesome.
Is that SDK? You mentioned that's going to be open source too, correct?
Yeah. So the like main components of it will be open source, because ultimately we want anything that's built for the light phone to feel like it fits within the UI framework and the design patterns that we have. Everything that's built for it should feel kind of like native to the device. So of course we'll be open sourcing, all of those components, so that folks who are building for it will be able to, just kind of pull in those components and lay out screens in the same way that we do in the the first party pieces of the phone. So yeah, we'll be open sourcing as much as we can around that. Sure.
That's great. I think it's going to be a lot of fun to actually dig into the source code and get a look at how it all works. So I'll definitely be keeping an eye out for that and looking forward to seeing it.
Yeah, definitely.
Yeah, there's a part of me too that I just have so much noise on my phone that there's a lot of appeal to me on a phone like this. At the same time, though, there are some things that I like doing on my phone that I don't know that you would ever enable on. But at the same time, I mean, a lot of them are a waste of time, like games and things like that. So
yeah, I mean, you can always substitute those things with talking to your loved ones and things like that. I mean, that's what the iPhone founders would say. They'd say, well, being more present in life is a better substitute. But I'm more with you, actually, because I run a business and I definitely need to answer emails on my phone, or so sometimes I have to log on to server clusters and make sure that they're auto scaling properly, and I have to do that from my phone because I'm on the run. So I'm probably more in the camp of someone who would use their light phone as a secondary phone, and just route calls to it when I wanted to, which is something that we are kind of like making sure to build out properly before we release to people. A prototype some of that and it works great, but it needs a lot more work for sure. But yeah.
So what does the business end of this look like? Because I mean, we're talking about the technology and things like that, but how are you selling it? How do you get the word out about it? Who's buying it?
Yeah. So one thing that a lot of people bring up when I start talking about this, and it's a a relatively new idea to that individual, is that they say, well, it's a cool idea, but it's like kind of niche. You're not going to have a very big like community. And I've been thinking about that. And my point of view really is that the light phone is a device for everyone, but it's only for individuals in a specific time in their life, right? Like we've probably all felt to some degree as being, extremely logged on people that we are, this kind of like feeling of internet burnout, like the feeling that you just need to get away from it. You need to separate from it. Everything's so noisy and you just want to relax and kind of like straighten your brain out. Like I know I've felt that at varying times in my career. And my feeling is that everyone kind of goes through that from time to time. And there are a subset of those people who are going to actually start looking around for like, what's a different way that I could be connected with like more constraint. So I actually think the customer base is actually pretty huge. It's a device for people at a specific time in their life to help them find respite. But the Light Phone 1 was originally founded on Kickstarter. And back then, that was, I think like 5 or 6 years ago, that device was much more simple. It just had a dial pad. It didn't even have a touch screen or anything like that. And it just had a basic LED display across the top that just basically just showed numbers and letters. And we built the desktop app for that phone, and it raised a bunch of money on Kickstarter. I forget how much it was, but the Light Phone 2 was on Indiegogo. I'm just going to quickly look up where it got to, because it really kind of blew our minds. The Light Phone 2 on Indiegogo did $3.513 million in pre-sales. And, that's like, I don't have the numbers on me, but I would say that that's somewhere between 7,000 and 10,000 phones that were purchased in pre-sale, just based on the back of this idea alone, this kind of philosophy, and also the design presence. It's a really beautifully designed device. And now we sell the device on thelightphone.com. You can go over there and you can buy the device. You can add a phone plan to it, and we'll send you a SIM card. And you can add a phone case, and you can go and check out, and that will give you a dashboard account, kind of like your iCloud account. It'll give you an account that allows you to sync your contacts to the device and to your dashboard. And we've been selling a bunch of them. I don't have a number for how many devices are out in the field right now, but based on the amount of, our server is running 12 instances on a Kubernetes cluster of like, an Elixir Phoenix app, and we are just keeping up with all of the traffic. So, there's a lot going on. And it's, doesn't cease to surprise me how popular this idea is and how much it resonates with people.
That's great. Building on the business side of this and kind of just exploring, what's going on under the hood there. How many developers are contributing to this total? And maybe also specifically, how many developers are contributing to building the React Native code that's going into this?
I'm glad you asked, because we like to say internally at our studio that we are running a telecom company with 4 developers. So there is me, and I do a kind of like a lot of the lower level and development ops stuff. So I run the server clusters, and I do all the deployments and releases over the air for the OS and things like that. We just have, and I will jump in and do OS development and UI development when I'm needed, but a lot of the time I don't do that type of work. We have one developer, Connor, who is basically kind of like owning the UI. And I also want to give a shout out to Alicia, who wrote tons of this UI code and OS code as well. And then we have Conan and Harrison, who are basically kind of like building a lot of the back end API and dashboard pieces for that kind of like SIM card activation step and those kind of like deeper telecom pieces too. So yeah, there's just 4 of us right now, and we are hiring. So if you want to work on a telecom company and you're a sharp Java or React Native developer or Elixir developer, please reach out.
Boy, we should get you on Elixir Mix.
Yeah, I mean, we've done some crazy things with Elixir too, and we are massive fans of that language.
Yeah, how much? I'm a little curious now, and I know this is a little bit off topic for React Native Radio, but so you have a back end. I'm assuming you have an app store and things like that, I guess, that are probably written in Elixir and some other technologies. But yeah, what are you actually building on the back end that users are going to need?
Yeah, so the majority of the back end pieces, or the API pieces, are written in Elixir and Phoenix, and that's just one big app. It's one kind of like mono repo. We do have a few microservices that are written in Node and kind of just running on as like serverless functions, but the majority of our API is written in Elixir. There are cases where we call out to like a card DAV server for doing contact synchronization. And those pieces are kind of just like out of the box Docker image containers that we have just customized a bit to our liking. But yeah, as I said, the majority of things are all running through this Elixir Phoenix app. And that app runs on Kubernetes and is right now, I think we're running about 4 Kubernetes nodes and 12 instances of this Elixir Phoenix app. Because we do have a WebSocket and real-time connections between the device and the server when we can manage it and when the device is on. And, there's a lot of kind of like considerations that go into making sure that the battery isn't draining too quickly, through a WebSocket connection. But yeah, we also have, a live connection to the server as well so that we can, manage things like if someone changes a contact in the back end, that contact will sync down to the phone as quickly as possible. Or if someone enables a tool in the dashboard, that tool will pop up within, microseconds on the device. So yeah, that's kind of what the backend looks like. And then the dashboard, we have like a proprietary admin dashboard, which, only super users can see. And then we have, the user-facing dashboard, and both of those are written in Ember.js. They're very kind of like CRUD-heavy apps, and we just needed to kind of like ship them very quickly. And I'm an Ember developer from way back, and Ember felt like a really good solution for those things, especially because we're using like the JSON API spec to serialize all of the JSON for all of the parts of the system. And then the front end that actually sells the device and kind of markets the device is just a regular React.js app that interfaces with that same Elixir server. So yeah, there's something like, I don't know, there's between like 7 and 14 programming languages in this system. I don't have a count, and it kind of depends on whether you're going to class HTML and CSS as some of those languages. I mean, I certainly do. But yeah, there's a whole lot of stuff going on in that backend.
Early in my career, I figured out which jobs were worth working at and which ones weren't, mostly by trial and error. I created a system that I used to find jobs and later contracts as a freelancer. If you're looking for a job or trying to figure out where you should go next, then check out my book, The Max Coder's Guide to Finding Your Dream Developer Job. The book walks you through figuring out what you want, vetting companies that meet your criteria, meeting that company's employees, and getting them to recommend you for a job. Don't settle for whoever has listed their job on the job board. Go out and proactively find the job you'll love. Buy the book at devchat.tv/jobbook. That's devchat.tv/jobbook.
This is super interesting. I guess what's cool to me is that you are such a small, tight-knit team, yet you have this incredible diversity of languages and technology you're using to build and ship this product. And it's really cool that I can tell you guys put a lot of thought into the kind of tools and languages that you're choosing to make this entire operation possible. So it's really cool that React Native has found a place and a good fit into this entire thing.
Yeah, definitely. I mean, as I said, like the two key reasons we chose React Native was to work with the screen in this logical and predictable way, and so that we could ship an SDK that allowed other developers to do the same. But a third reason why React Native was such a good choice is because going into this project, we as a team couldn't really write much Java. We weren't experts in Java. We could all write a little bit, and we'd all kind of like messed around with Spring and things like that. But none of us were experts in Java at all. And using React Native allowed us to kind of like take developers who are used to writing, React Native apps or even just React JS apps and jump in and start shipping UI code in the very early days of the project. And what that meant is, the UI kind of came together with like a lot of stubs because, we're using Redux and we're using, Redux Saga and handling everything through promises, in this kind of like headless Redux context that calls out over the bridge. And we were able to kind of like just mock a lot of things with timeouts and kind of like build the shape that we want to be passing around, in the React Native app. We're using Flow so that everything is strictly typed. And what it meant is I could jump in, I could start fleshing out some of that Java stuff while the UI was maturing very quickly before those developers were even ready to kind of like jump in and start learning some of the Java they needed to learn to build out, the back end to their React Native components. So I got to say it like helped us go from 0 to 60 in terms of getting some UI on this phone from day one.
Yeah, that's such a recurring theme that when I talk to developers that comes up over and over again. It's just, React Native is in a place right now where it's so usable. It really is performant. But at the same time, it just allows you to do that 0 to 60 and really get rolling on something. And it lets you draw on the existing JavaScript community knowledge and all this too. So that's great.
Yeah. No, it was awesome. I think we, kind of chose the right way about going about things, given that we are a small team and we are shipping software very quickly. In a perfect world, we might have written this all in native XML and, using inflators and managing all of that UI imperatively. But that we just didn't have the time. Building a cell phone is incredibly time consuming, and we were already on a very short timeline. So it helped a ton. Yeah, I got to say.
Cool.
Well, I don't know if I have any other questions. Tim, do you have anything else you want to bring up?
I do have one final question for you, Hugh. So looking back now, your team has built something really interesting. You've had to solve a lot of challenges along the way. Certainly it was a long road. If you could maybe go back in time with all the knowledge you have now, what things would you, what kind of advice would you give yourself, especially going down this rabbit hole with React Native as an operating system?
Oh, I don't know if we've got enough time to go through all of the things we do differently. I mean, ultimately, I'm really happy with the software and how it turned out. It's incredibly stable. It performs really well. There aren't many major things that I would change, but I would say that, and this is like a little one. I would say that being even more diligent with bug reporting and we use Sentry for basically all of our bug reporting for all of our UIs, including the OS and handling exceptions. And I would say that there's a couple of places where, as we were rolling things out, there were a couple of places where we weren't capturing exceptions with as much detail as we would have liked. Because when you're running React Native, you're running this JavaScript instance, and then you're running also, the Java instance, or you're running the actual app on the, in Android. And the exceptions can occur in both places. You can have exceptions that occur in JavaScript, or you can have exceptions that occur in Java. And we found it a little difficult to kind of like unite and handle all of those exceptions in a way that we could very easily find, debug, and fix those problems in the early days of rolling out the OS. We've gotten a lot better at this over time. But just having like a more strict and diligent pattern for reporting exceptions is probably the main thing that I would have worked on, so that we could fix things a lot quicker.
Very cool. I think that's advice that, all of us React Native developers can relate to.
Yeah, it's always kind of an afterthought, but then, with an operating system, so many things can go wrong, especially just like dealing with telemetry. General is like crazy. Like we had one thing we didn't preempt, which, we just would have never found in our testing, is that a small percentage of users would have MMSs that came in that were email addresses. They weren't phone numbers, they were email addresses. So you'd be in a group text thread and one of the users would have an email address. And that, in the early days of the LightOS, would brick the phone. You would have to basically get a new update shipped to the device to fix that. And it took us way too long to figure out that it was an email address in the recipient list that was causing that. So yeah, just little things. Like, so much can go wrong when you're building like an operating system for a cell phone, that you want to be capturing those exceptions like crazy. So yeah.
Yeah. Oh, that takes me back. My first full-time development job, I worked for a company that did consulting. And so they farmed me out to a company that was putting together basically a text message based system to connect people. Of course, this was like 15 years ago. And it was all kinds of wacky stuff that you get from the cell exchanges. And yeah, a lot of people don't know it, but yeah, you can email within the US at least. And I don't remember all of the domain names, but you could email like phone number at verizontext.net or something. And so it's when what he was talking about, it's even transparent a lot of times to the user. They don't know that it has an email address in there as the recipient. They think it's a phone number, and then there's something in there that's translating it along the way so that it winds up in the right place. But yeah, down at the lower level, you have to be able to handle that because it's just one artifact in the system that makes it work.
Yeah. Mm-hmm. It's a wild world.
Yeah.
Telemetry is an very old technology, and it's just littered with all these edge cases that we just weren't ready for.
Do you have to do much carrier specific programming?
No, we haven't done any.
Okay, that's good.
There hasn't been any that I mean, on the lower level, there are definitely cases where we need to handle different carriers and different bands on kind of like the modem level, right? Like, we have a Qualcomm chip, and there have been cases where certain carriers don't work with certain other handsets in very specific cases. And those things have to be shipped through like basically an update to the running firmware. So that's even lower level than Android itself.
Mm-hmm.
So there has been a little bit of that, but on our level, like from that Java side up, no, we haven't had to touch any of that.
Yeah. Well, 15 years ago, it was such a pleasure to work in. Pardon my sarcasm.
Yeah. I share your pain. Don't worry.
Yeah. No, I hear you. Well, if people want to learn more about LightOS, where do they find all that stuff?
Well, so first of all, you can go to thelightphone.com, and you can actually buy a phone there and kind of just learn about the company and the philosophy and the hardware and everything, at that website. But my company is actually called Sanctuary Computer. We're a software consultancy here in New York, and LightPhone is one of our biggest clients. And if you want to learn a little more about the technology behind the LightPhone, I would encourage people to go to our Medium, which first you can go to sanctuary.computer. That's our URL. And then you can find our Medium from there. And there's a big article on there that kind of breaks down how to build a version of the LightOS. Like if you followed through with that Medium post, you would probably have a pretty good understanding of how to do this at home on your own. And we've also got a bunch of other things on our Medium that are actually quite interesting. The way that we run our company is highly transparent. We open source all of our profit and loss statements every year. We have an egalitarian profit share. We cover everyone's health insurance 100%. And there's a bunch of writing about how we, quote technology and run our consultancy in this kind of like, transparent and open source type of way. So there's some other interesting stuff on our Medium that I think your listeners would really like. Nice.
Good deal.
Yeah.
All right, I'm going to ask you again, Tim, anything else we should bring up? Or Hugh, is there anything that we didn't talk about that you wanted to make sure we covered?
There's nothing major. I think that we covered most of it. Yeah. It's such a huge project. Like, we could talk for days about some of the very specific things, but yeah, I really wanted to keep this focused on the OS itself. So yeah.
Nice.
Yeah, I'm all set on my end.
All right. Well, let's do some picks then. I'll go ahead and start us out with picks. So I've been talking to a few people, and I guess I'm kind of toying with this because I've done it in the past. I hadn't done it for the last few years. But a lot of people, in light of the coronavirus and things like that, have been asking for remote conferences. And it had kind of been building a little bit last year, but yeah, now that people are actually getting sick and getting worried about getting sick, and just, I guess, just to be a little bit transparent, I hear some people that are super alarmed about it, and other people who are talking about like it's not going to be a big deal and it's being overblown, and I don't know who to believe. So it's entirely possible that we'll have a remote conference, and it won't be that major a deal in the U.S. But it's also, I guess it's possible that it'll go the other way, and it'll be nice to not have to shake people's hands and worry about that. So anyway, so I'm going to be putting together some of these conferences. One of them is going to be on React Native. I'm trying to figure out when to do it so that it doesn't collide with Chain React, because I want people to be able to go to that conference as well and not feel like they have to pick. So if you are looking for a conference to go to, I highly recommend Chain React, and I'm going to pick that. That's at the end of July. And then I'm going to be putting on a React Native remote conference, and I don't have a domain for that yet, but if you go to devchat.tv /conferences, you'll be able to find it on there. And so I'm going to shout out about that. And then I've also been putting together a course on how to do podcasts. I've had a number of people ask me questions, and I try and help them, but I don't always have a ton of time. And so I'll kind of give them enough information to take the next step. But I am putting together a course for that. So you go to courses.podcastplaybook.co, not .com.co. Then you can actually pre-order the course. And by pre-order, what I mean is if it's after March the 9th, which it should be for this show, there will be some content in there. And I'm planning on just getting a couple of videos in every week until the course is done. So it'll walk you through how to get artwork done, how to set up your website, and on and on and on and on. It'll probably walk you through on the website stuff, setting it up in WordPress, and then how I have things set up on static site generator like Gatsby or Gridsome or something like that. So anyway, we'll walk through a lot of that stuff and show you how to do it. Right now, it is $497 for a ticket, or for the course. I plan on selling it at $997, and I'm reasonably certain that once it's done, I will easily sell plenty of them at that price. So if you want to get in early, yes, you're going to have to wait for some of the videos, but you'll get it for half the price. So anyway, I'll have links to all that stuff in the show notes. Tim, do you have some picks for us?
I do. I have 2 picks today. My first pick is, recently some gameplay videos came out for a video game called Half-Life Alyx. To anyone out there who is a fan of Half-Life 2 or Valve games, I'm super excited for this. It comes out March 23rd, and it is the first really high budget, like 15-hour long experience in virtual reality. The gameplay trailers were super cool. You have the player moving around in environments. At one point, they get into like a gunfight with these like alien soldiers, and they're like grabbing car doors to hide behind while like firing through the windows. It is awesome. You should definitely go watch the gameplay for it. And if you're in a position where you have access to VR, you should totally play it when it comes out. I am super pumped for it. My other pick is a little bit more self-promoty. I have a blog on dev2, that's dev.to. If you just go to /Tim Jung, specifically, I wrote an article called My 2019 Year in Review, working on the Call of Duty companion app. And really why I wrote this, and why I think it's cool for people to read, is it's just a recap of kind of my portfolio of what I did on my team over the last year, what I contributed, and the features I built. So if you want to read it and talk to me about it, I answer pretty much all my Twitter DMs. I love answering questions for people who are curious about things I've worked on. So please feel free to do that.
Nice. Hugh, do you have some picks for us?
Yeah, I have a couple. Well, it's not really a pick, but I'll just give a quick plug again. As I said, we're hiring at Sanctuary Computer, www.sanctuary.computer. Get in touch. We're super friendly, and we would love to chat. But my
React
two
Native
picks,
developers or?
Oh yeah, we're looking
others?
for React Native. We're looking for React. We're looking for people who are just generally good at JavaScript, functional programmers, test-driven developers, everything under the sun. We really like Rails, and we really like Elixir Phoenix, and we do a lot of JavaScript and modern kind of stacks. So
Nice.
Yeah, if that describes you, please get in touch. And yeah, so my two picks. The first one is a system called Lumen. I'm not sure if this has been on one of your podcasts before, James, but basically it's a implementation of the Beam, or the Erlang VM as it's also known, but it's targeting WebAssembly. So the idea is that, you can write Erlang or Elixir and compile it down to native code that can run in a WebAssembly environment, and kind of bind into all of the DOM APIs and allow you to essentially write really high performance user interface using, all of the resilience of, a process supervision tree and, all of those kind of like functional paradigm pieces that you get with Elixir. So that's something that I'm incredibly excited about. It's early days yet, and it's being developed by some folks from Dockyard in Boston. And, they've been leaders in the Elixir and Phoenix space. So I'm sure they're going to do an incredible job of this. So that's one thing. And then my second pick is Project Ren. So Project Ren is a service that allows you to offset your own personal carbon footprint by paying monthly subscriptions based on kind of like a calculation that you put in. So you go through and you put in how much meat you eat, how much you travel to and from work, how many flights you take, long haul and short haul, things like that. You essentially develop an average carbon footprint for your own, personal existence. And then, it allows you to pick, some type of carbon offset you might want to buy. For example, my carbon footprint costs me something like $9.53 a month. And that money goes to planting trees in Africa. So I think it's a really cool project, and it just helps me feel a little bit better about my day-to-day life. So yeah, it's cool.
All right. And did we get social media links and stuff for you?
No, I don't think so. On the doc that I sent over, but I'm @_HHFF on Twitter, and our company Sanctuary Computer on Twitter is @SanctuCompu. So SanctuCompu, and that's the same on Instagram as well. So
nice.
Yeah, that's us.
All right. Well, thank you for coming.
Yeah, thank you.
Yeah, thanks so much for having me. Yeah, I've been listening to the podcast for ages, so it's really great to be on.
Good deal. All right. Well, we'll go ahead and wrap this one up, and we will be back in a week. Max out, everybody.
Later, guys.
See you, everyone. Thank you.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.